The next generation of chips will be made out of glass, and this will spark a new era in electronics. TSMC is already actively working on this technology, which is driven by demand from NVIDIA and Apple. Intel has already a fully functional glass chip prototype, and this goes on top of a lot of exciting research published on this topic. I'm very excited to see another semiconductor revolution coming. So, why glass and why now? If you take any chip, you can't have one without a substrate. For example, AMD's MI300 AI chip is built of certain pieces of silicon that behave as one single chip, and they are all integrated on top of this beautiful green substrate. Its function is to redistribute the signal so chip can communicate electronically with the motherboard. Over the last 20 years, this substrate was primarily made of organic materials or plastics, and it's quite cheap, so it became an industry standard. And the biggest material shift in the semiconductor industry over the next decade or even more is going to be the replacement of this substrate with glass. But why glass? Actually, driven by the demand for AI, acceleration, and high-performance computing, we are shifting towards larger and larger chips and stuffing more and more chips in a single package. Today, we use 2.5D and 3D packaging technologies, but 4D, 5D, 5.5D packaging is on the way. At the current pace, the existing technology is expected to run out of steam already in the second half of this decade. So all the key players are already transitioning towards glass. But why glass? Actually, glass has some great physical properties. First of all, because glass is rigid, we can build a bigger designs with that. We can build a more stable substrate for larger chips, over 100 to 100 millimeter in size. And with glass, we avoid distortion or bending of any kind. So with glass, we can package more chiplets together and increase transistor per area ratio. For example, in one of the recent papers, Georgia Tech showcased how they mounted 60 chips on a glass substrate. And it's about 4 times more of what's possible with the current TSMC CoWoS packaging technology. So the first adapters of glass are gonna be, of course, high-performance chips, those that are AI accelerators and chips for data servers. And there is a lot of exciting research ongoing in this field. For example, in one of the recent papers, researchers from Georgia Tech and Meta designed a chip where they used glass to integrate logic and memory chiplets in a 5.5D system. So 5.5D packaging. That's interesting, right? 5.5D is a novel concept that combines 2.5D and 3D stacking. And this work showed that using glass instead of silicon or organic materials provided huge improvements in area, power, and signal integrity. And we will talk more about this later in the video. Another big advantage is that we know very well how to handle glass. So we can manufacture it to be very flat, very thin, and very smooth. And this is essential for photolithography. Photolithography is one of the key steps in the chip manufacturing process, and it's used to create very tiny patterns on a wafer. Basically, with that, we transfer integrated circuits design on a wafer. And this requires a very flat substrate to start with. The problem is that an organic substrate doesn't have this lattice structure like semiconductors. So if you look very close at it, it's like this. And this non-uniform structure affects, of course, a lot the precision of lithography and in general the signal propagation. So when we transition to glass, we can achieve more precise lithography with finer feature patterning because it's perfectly flat and smooth, and this will allow us to place components closer together for any given size. And in this case, we can uniformly expose the entire wafer, so it gets less defects and better costs, and this is essential for the continuation of the Moore's law. If you are not convinced yet, I have another great property of glass for you. It has a very low dielectric constant, and dielectric constant shows how well a material can store electrical energy. So the low dielectric constant of glass shows that it's not good at storing energy. And it perfectly makes sense, right? It's a glass. But why do we care? weaker because of so-called RC time constant, which is essential. It has a huge impact on how fast the chip can work. In the RC constant, C depends on the material, on its dielectric constant. So glass having a low dielectric constant means that less energy spent on the parasitics. So all in all, it allows for faster signal propagation and higher frequencies. And we love that. Now, when it comes to glass chips, those are typically manufactured at rectangular wafers, 650 to 650 millimeter in size, so quite big wafers. They come in rectangular shape from the very beginning because a molten glass is formed into thin rectangular sheets and then remained in this shape throughout the manufacturing process. But actually it doesn't make really any sense to compare these two technologies, silicon wafers, circle in the round shape, right, and rectangular wafers. But I just wanted to mention that with the rectangular wafers, we get more chips and less waste. Of course, transition to glass will require the majority of assembly line equipment to be replaced, and this requires substantial investment. Now, when we're looking from the perspective of consumers, to us, of course, the most exciting property is transparency. Finally, companies are offering more transparency to us, and the semiconductor business is becoming a clear cut. Of course, it would be very exciting to look at this nanometer world through the glass, right? I definitely say yes to this. I actually tried to open up one of the AMD Ryzen chips, but it turned out to be a flip chip, so I messed it up, which you will see in one of the next videos. So make sure to subscribe to the channel, not to miss it, and leave me a comment below. What do you think about the glass technology? I love reading your comments. In reality, glass wafers doesn't mean that the chip will be transparent, unfortunately, but I totally love this idea. Another huge advantage of glass is thermal stability. It has a very low coefficient of thermal expansion, at least 5 times lower than organic materials. It's just better at managing heat, and it remains stable with temperatures typically up to 600 degrees Celsius. And thermal management is one of the biggest challenges for the modern GPUs, AI GPUs, and AI chips. So glass is a potentially amazing solution to this problem. You know, when a chip is working, when it's processing data, a current flows through its tiny circuits, creating resistance. And this resistance turns some of the electric energy into heat, so the chip is heating up. And the more data it processes, the hotter it gets. So this is a huge problem for the AI accelerators and GPUs, because it's crunch a lot of data nonstop. So when it gets too hot, the organic substrates start to degrade, and it can wrap and bend, and this often leads to structural deformation and connection failures between the parts of the chip. In the previous video, I discussed the problem with the new NVIDIA Blackwell GPU, which is being delayed, and it seems that it has to do with the thermals, so exactly this issue. And because this GPU is a relatively large design, it shows that we bumped into the limits of what the organic substrate can handle. What is so interesting about glass? Glass has a coefficient of thermal expansion similar to the silicon. And it kind of makes sense because both glass and silicon contain silicon atoms, but their electrical properties are very different. Silicon has a crystalline structure and it's a semiconductor, while glass typically has a non-crystalline structure and it's an insulator. But because the thermal coefficient of glass is very close to the silicon, they expand at high temperatures at the same rate. So when we combine glass substrate and silicon chips, we can avoid any thermal stress or bending or wrapping of any kind, even for the largest designs of the future. So this technology has a huge promise, and I really hope that glass won't break it. As you can see, it's a very hot topic in semiconductor industry, and so a lot of research ongoing. And in one of the recent papers, Huawei integrated a diamond onto a glass chip. And this is a very interesting combination because they use glass as well as a diamond on top as a combination designed to create better thermal management. And with that, they achieved a 30% reduction in thermal resistance, which is in simple words means that it's 30% better at transferring heat away from the chip. So, of course, TSMC is also working on developing glass substrate. It will be used in their fan-out panel level packaging, which is being hugely driven by the demand for AI accelerators. This technology will be based on the glass, and of course, NVIDIA will be one of the first adopters of this technology. TSMC is targeting 2025-2026 for glass substrates to hit the market, and they are hugely anticipated. Companies like Intel, AMD, Samsung are already working on glass substrate production. I've already mentioned TSMC and some research papers, but of course Intel is at the forefront of this technology. They've already established a dedicated research facility in Arizona for this purpose, and they even already built a fully functional glass core chip. They plan to be the first to commercialize the glass core technology and plan to mass produce glass chips by 2026. And they are already working on it, while I'm working on some exciting material on Intel for my weekly newsletter. If you want to receive it, subscribe to my newsletter through the link below. Following Intel, Samsung already has an R&D division working on glass substrates. AMD is also working on the first glass chip prototypes, and they are trying to establish a supply chain, preparing for the moment when glass substrate hit mainstream markets. Also, some new players emerge, like Absolix, who received a substantial investment and now they're building a dedicated fab for the glass chips. And at this point, not only semiconductor companies, but also equipment suppliers, material and chemistry suppliers are getting involved. So the race is on. Of course, like any technology innovation, this development requires a lot of investments and possesses huge risks. Taking into account how easily glass can shatter, it requires extra careful handling, and some processes have to be adapted for it. If you remember what happened to a couple of silicon wafers, you know that I should definitely not get involved in this. In reality, these wafers won't be made of a pure glass, it will be some proprietary mixture to achieve desired electrical and thermal properties, so I guess it won't be as fragile as a typical glass. Of course, establishing a mass production gonna be a huge challenge because it requires huge shifts in manufacturing processes, and it's gonna be definitely a costly transition for the industry, which will still take some more years. So for now, Intel and other companies are figuring out the most effective type of glass to use because we need to bring the costs down. And we need to figure out some processes how to prevent edge cracking or just breaking during the transport and handling. But once we get processes figured out, there is so much more that we can do with glass, and we haven't even scratched the surface. It has high frequency benefits that we haven't even discussed today. It allows for more efficient power delivery. It also can be seamlessly integrated with optics. So it has a huge promise. Let's hope it doesn't shatter our expectations. You know, it's sad to make this world better. And my friends at Planet Wild are already making this world a better place. Planet Wild is a community of people who are helping restore our planet one mission at a time. I joined them this year and I've been really impressed by their work. Each month they go on different missions, including forest and prairie restoration, cleaning up oceans and protecting endangered species like the European lynx, little owls and blue whales. All these projects are supported by a membership model from people like you and me, and I really loved their latest mission to restore America's Wild West. North America's grasslands were once full of thriving wildlife, but overhunting and farming caused the decline of many species, taking away its natural beauty. In this mission, Planet Wild is helping to restore the prairie unique biome by reintroducing iconic species like bison and pronghorns, bringing back the wild beauty of America's grasslands. What I really appreciate about Planet Wild is their transparency. They document every single mission on their YouTube channel as well as their app. And honestly, each time I'm watching the report on their mission, it makes me infinitely happy. Join us to make the Earth a better place. You can join by scanning the QR code here or join through the link below. And the first 200 people who will join with my code Anastasia29 will get the first months paid by me. And the best part, he will already make a real impact in the first months and see the first video report in the less than 30 days, on the 15th of the following month. If you would like to learn more about Planet Wild and their work, check out the latest mission here. Make sure to connect with me on LinkedIn. The link is below. Subscribe to the newsletter. Thank you for watching till the end. Love you guys. See you in the next video. Ciao!